Welcome back, class. Welcome back. So this is our 1332 liberal arts math class, and we are getting ready to take a financial test. And so your instructor is working out the test review problems that were generated for the instructor from the MyLabs Plus review handout. And so your problem should be very similar. Your 20 problems should be very similar, except the numbers are going to likely be different. Okay, but this will help you as you get ready to study for your test. So this is our second part of the taping using Zoom, and we're on problem number 8. So let me show you what problem number 8 says. So it says determine the present value P that must be invested to have a future value A at a simple interest rate R after time T. So the A is noted at 9,000. The rate is 9%, and the time is given as 9 months. Okay. And then although they have a note to round up to the nearest cent, they want you to round, sometimes they want you to round to the nearest dollar, and sometimes they want you to round to the nearest cent. But although the book, if you read through your ebook, and your ebook makes a note in this section about this formula that when computing for P, when finding P, which is the money needed to achieve some type of a goal, some type of a financial goal, we do have instructions to round up. And why? And it's rounding up is a little bit different from just rounding. If you're rounding, you look at the neighbor to the right. If it's 5 or more, then you add 1 to the value you're rounding to. But when you're rounding up, regardless of that neighbor being 5 or more, you always increase that digit, rounding up all the time. And you do that so that you don't fall slightly short of meeting your financial goals. So you either round up to the nearest dollar or you round up to the nearest cent, depending on what they're asking you to depending on what they're asking you to round to. So we only do these for problems in this financial formulas, just financial tests, when you're trying to find P, okay, when you're trying to find the money. And so determine P, the money to be, in this case, invested, all right? So let's keep that in mind. And the formula that we need for this will be this formula. So we're still in this simple interest, but we're using A equals P times 1 plus RT. And what I'm going to do is I'm going to solve for P. So I'm going to divide both sides by 1 plus R over T so that I get this. P is equal to A divided by 1 plus RT. So the reason why I'm using this simple interest formula as opposed to something on this side, as opposed to the compound interest, because there was no mention of the money being compounded. There's no mention of the money being compounded at any point. And so that's why I need to use this formula related to simple interest. Okay, so we're gonna work with that. So let me write that down. So 8, and let me write down that formula from the paper here. So A equals P parenthesis 1 plus RT, and I'm going to say solve this for P by dividing by 1 plus RT. Okay, so I'm going to show that. I'm going to divide this by 1 plus RT on this side, divide by 1 plus RT, and then these will fall out. This will divide out, and so we're just left with P equaling A divided by 1 plus RT. Yeah. Okay. And then if you want a reference page for that, let me look, let's see. That should also still be in section 8.3 under that simple interest. So if you want to reference to that, you should be able to find some information there. The other thing that's also helpful in section 8.3, well, and not throughout the whole book is the technology part. They have a technology aspect also where they talk about the calculator. Even though your calculator, your TI-30XS, is not a graphing calculator, they make use sometimes to a scientific calculator, and then sometimes they'll say a graphing calculator. But a lot of times your calculator, even though it's not a graphing calculator, it has this mention of a caret key, which sometimes when you look at the keystrokes in the graphing calculator, you'll see it's very similar. But there are some technology boxes on the side, aqua blue boxes throughout the book, that you want to look for that. And let's see if I can show you that here. Let's see. This here. Yeah, so you see, so it's good to take a look at both of these. They have a scientific calculator reference, and then they have a graphing calculator reference. But sometimes your TI-30X has the keys that the graphing calculator has, and they share that. So if I look at both of these, they're talking about taking 8,000 times this exponential, right, this E value, E raised to this power, that's a rate times time. Yeah, so these actually, if I were just to show you this here, they may not always match up correctly, but like if I were going to type this problem just for practice on the calculator, and I know we're not doing a continuously, this is for continuously compounded. I know we're not doing that, but this is just, since I'm mentioning that, if I were going to type this in, I would turn it on, I would do 8,000, and then I would hit my second, and then my LN key, because see, that's where my EX is at. See how that raises it to a power? And then what I would do here is I would have multiplied this value first. Let me go back. Let me take this off. I would have first found out what is 0.0685 times 6. 0.0685 times 6 is this value, 0.411. And then I would have done the 8,000. And then second, raise that to the E, so second LN. So this is green, see that? It's green. And then I would have typed 0.411, and then the enter button. See the enter down here? And the enter button. Yeah, and it would have been nice if they had put the answer. I don't even see the answer there to check the work there. I was hoping to check the work. But yeah, that's what I would have done. Then you would round to whatever they ask you to round to. So yeah, so see that these keys right now don't exactly match. I don't see too much of a match on what they're typing here for that. Okay. All right. So, but I have seen some of the technology checks where I look at them and they do match along to what your calculator has. So it's good just to look at them in case you need a reference for that. Okay. And so, yeah, but 8.3, this section 8.3 is where you would see this idea of the simple interest, okay? All right, ideas. Okay, so now, let's go back to this problem here. So and you wanna write this on your paper, P is equal to A divided by 1 plus RT, and know that that gets, like that's like an offspring, like this is the parent function, right? Or the parent formula, and this is like the offspring formula that we get off of that. So I just divided both sides by 1 plus R over T, and I'm going to solve for P. All right. So now when I plug this in, so I can say P is equal to, and so the A was that 9,000. Okay. So that was the future value. Have the future value A. Okay, so that's our 9,000. It's our goal, divided by 1 plus R, and the rate was 0.09 because they said it. They said the R was 9%. So remember, that's 9 divided by 100. You move it 2 places to the left. Okay, that's 0.09. Okay, and then times T, and the time on that, they said the time was 9 months. Okay, 9 months. So you want to put 9 out of 12. There are 12 months in a year. So that's 9 over 12, okay? And then technically this would get closed up, right? All right, now 9 over 12 terminates. So time is 9 months, so we're using that as 9 over 12, and I believe that terminates. If I just do 9 12s, and there shouldn't be any harm in doing this here. If I do 9 12, it shouldn't be any harm. 9 over 12s, and let me just see if it terminates. If I do 9 divided by 12, yep, that equals 0.75. Yeah, so that terminates. That terminates. It's not a repeating desk. So I'm going to choose to use that. So I basically have 9,000 over this 1 plus 0.09 times 0.75. Yeah, and that's kind of what I've got there. Okay. And then now what I can do is multiply 0.75 times 0.09 and then add 1. So 0.75 from 9 divided by 12 times 0.09 is 0.0675, and then I'm going to add that 1 to it, plus 1. Okay, so now I have 9,000 over 1.0675. Yeah. Okay. Yeah, and I would do that. I would do that. So it terminated, 9 over 12 terminated, gave you 0.75, and then times 0.09, and then plus 1. So now you're just working with that. So now you have just 9,000 divided by 1.0675. Okay, so now I have 8430.913349. Okay, and then they wanted you to round to the nearest, they did say round to the nearest cent. Okay, now this is not 5 or more, so technically this is going to be 91 cents, but the thing is, and I'll write that here, but there's a but, 8430.91 cents. Okay, but remember what the book said, when computing P money needed, so when computing P, okay, you're advised to round up to not come short of financial goals. Okay, so we're actually going to say that P is approximately 8430, and on the change like 91 cents or 92 cents, we're going to round up to 92 cents. So I'm rounding up. Okay, so remember, when computing P, which is money needed to achieve financial goals, you want to round up to not fall slightly short of meeting future goals. So you either round up to the nearest dollar or you round up to nearest cent. So this one was saying round to nearest cent, but I know that this is not 5 or more. I know this looks like 91 cents in the rounding when you round to nearest cent, but since this is a P, we have instructions to round up. Only for P, not for any other letter. Not when you're finding A, not when you're finding R, not any other letter. It's just when you're trying to find P, you've got to make sure you don't come short of your financial goal, and you've got to round up, okay? And the other thing is, you know, the 912s, if you wanted, I mean, 912s terminated and they gave us 0.75. If you wanted to like work with, work across, like, you know, this, the way we multiply fractions is straight across. I mean, if you were to play with some of that on the side here, like 0.09 times 9 and then divided by 12, you see, you still get that 0.0675, and then you add that plus 1. See that? Even if you start off with the 1 first, 1 plus 0.09 times 9 divided by 12. Let's see if we get the same thing. We do that. You know, we still get 1.0675. Okay. And so right away I saw 912s terminated and it gave me 0.75. So I worked with that. The other thing you could do is reduce 912s. 912s does reduce by 3, doesn't it? 9 divided by 3 is 3, and 12 divided by 3 is 4. So you see there's 3/4, and you're probably real familiar with 3/4. That's 0.75, which is 0.75. Okay, so you could have easily have had 3/4 in here, but 3/4 is 0.75. So if I do 0.09 times 3 divided by 4, gives me this, still that decimal, and then you have to add that 1. Okay, so either way, you see I'm doing this several different ways. I'm getting the same value in the denominator. Okay, and I don't always make use of this key, right? I didn't even make use of this key. There's not always a need for that key. You saw I did this work without it. Okay, because this terminated. See, this terminated. So I just multiplied that, like in the PEMDAS, doing what's inside grouping symbols, and then multiplying, dividing like from left to right, and adding. So I multiplied this out, and then I added 1, and that just gave me that. So I just had this divided by that. So I suppose here, when I had this here, suppose I could have done this in the key right there, and then done 9,000 over 1.0675 as well, and we still get the same thing. So I'm just giving you some variations, and we're still showing it work. You have to have the formula. So this formula, I'm telling you on your paper, you can jot this down here. If not, you have to start from scratch and then show me that you're dividing by 1 plus RT, but you do need your formula either way. And then you do your substitutions. Substitute A, this is your goal, right? You want to have, you go back to 8, determine the present value P that must be invested to have this future value A. So you're trying to meet a goal of 9,000 in a certain amount of time. So like, how much of a lump sum do I have to put into the account? And it did say simple interest. It didn't say any word about compounding. So you know not to use the other formulas, because there are other formulas that have P in the compounding part, right? Like this has a P in the compounding part, okay? And so, and this, I would say this P is different from this PM. PM is, let's see. Well, when we get to that, it's a form of a payment as well. So let me hold off on that. But the main thing is when you're trying to, let's see, let me take a peek at that, the annuities. Let me just make sure, since I've got the PM there. Yeah, I was looking like ahead, like at problem 19. Problem 19 uses a PM. So I do have a note that PM is the same as P. Yeah, I do have a note that PM is the same as P. Yeah. What's not the same is PMT. PMT is like it's like a payment. So that's PMT is different. But the capital P and this PM can be, idea is treated as P money, like money needed, right, to achieve some type of a goal. And so, let's see, determine the present value P that must be invested. Yeah. So you're trying to meet a goal and you want to find out, well, how much do I have to put in? I need to meet this financial goal, and how much do I have to put into the account, right? So you need to find out this P, this payment, right? This capital P value, this money that you need to put in to meet some type of a financial goal. So the thing is, the reason why I didn't use this formula is because it didn't talk about compounded interest. It just said simple interest. And so it said simple interest. Okay, it didn't say compounded, not compounded interest. And so I had to solve, determine the present value P. This is the unknown. Determine the present value P that must be invested. So you're trying to find out, well, and it's a lump sum. It's a lump sum that you're investing. Because what happens later on, like over here, in the annuities, for example, you're putting in money regularly every month. Every month, for example, you're regularly depositing money in the annuity. Like, for example, you're going to put in money and then have a nest egg, right? So when you retire, right? So you're repeatedly putting in money, and that's those kind of idea. The idea of having a financial goal. You want to have a financial goal at the end, and you want to be putting in money regularly. So this is more like the annuity. Whereas over here, you're putting in this lump money at one time. Just one time you're putting in the money, and then you're going to sit back and let it accrue, right? Like interest. But there's this one, simple interest. And sometimes we'll have some problems where it's compound interest. So I hope that makes sense. And so I'm trying to help you understand, to know, how does she know which formula she's using? Why did she know to use this formula? Because it just said that it was simple interest. It didn't have any word about compound interest. So I didn't have to come into here. I just had to work with this, but I still had to solve for P because it said determine the present value. So how much do I have to invest so that after 9 months, then we want to have $9,000 accumulated, saved up. That's your financial goal. And so they're saying that you would have to have almost $9,000 put in. You'd have to have $8,430.92 put in. So it takes money, right, to make money. That's saying to make money, it takes money to make money, right? So you'd have to have quite a bit up front, and then how many months was it they said? And 9 months, so less than a year, you're going to have $9,000. Okay, so let's see how much if I just do $9,000, how much are we making? $9,000 minus $8,430.92. So you're making $569 extra money. And that was in 9 months. If I just divide it by 9, how much every month you're making an extra 63, right? $64. Because it's sitting in the account accruing simple interest. Okay. Okay. All right, so that was number 8. And remember to round up anytime you're finding a P, to round up. And those are going to be just good distractors on your test. A good distractor on your test, like if it's a multiple choice test, a good distractor on a test would be to have both of these as answer choices. And of course, this is the right one based on your text. When you go through and do the reading, they said when you're computing for P to round up, okay? And so this would be a good answer to have as a distractor that would not be considered the correct answer. And so just keep that in mind, because these would be good distractors to put in to see if you're remembering that. Okay, they told me to round up for P, all right? Okay, let's look at 9 now. Nine says that suppose you have $15,000 to invest. Which of the two rates would yield the larger amount in just 1 year? Is it the account where you got 8% that's compounded quarterly? Or is it the account where you have 7 86/100% compounded continuously? So which of the two rates would yield the larger amount in 1 year? Okay. And so I'm gonna work both of these out and compute their values, and then let's see which one's larger. And then this is just, you can check our answer. They're saying which one's going to be larger, but let's double check that. So it's number 9. Okay, so we have this formula for compounding interest. Let me write this down. So we have this formula for compounding interest. You saw that it was compounded quarterly. And this would be that it's paid n times a year. To calculate the amount. In an account, okay? And so we're using this formula, capital A is equal to capital P, 1 plus R over N raised to the NT power, okay? So P is going to be the money to invest. Okay, and it's going to be, you know, sum, lump sum. So you're not making deposits like every month regularly. You're just making one big lump sum deposit, okay? And so on your formula sheet, we want to come over here to this formula here, okay? And because it says compounded, it said compounded quarterly. So that's why I'm going to use this formula here. Okay. All right. So then I have A is equal to P is the money to invest, which was they said, suppose you have $15,000 to invest. Okay. And the rate they said was 8%. So remember 8%, 8 divided by 100 should give you 0.08. So if I show you that here, 8 divided by 100, or you move your decimal 2 places over to the left. And then N, they said compounded quarterly, okay? So quarterly, let me make a little chart here. Let me make a chart. So let me say quarterly compounded. Okay, and this is number of periods per year. So when it's compounded quarterly, that would be 4. Okay, and then the length, what's the length? The length of the period, that would be 3 months. So, you know, in a whole year, there's 12 months. So every 3 months, they would accumulate, right? Accrue a new amount, some interest earned, right? So this is a formula for compounding interest paid in times a year. So they're paying it 4 times a year. So every 3 months, they have a new interest to add on to that, okay? And so we're dividing this by 4, and then NT, 4 times T, and the T was, let's see, the T was just 1. They said it was amount in 1 year. So 4 times 1 is 4. So the T was 1 year. Okay, so I have here T is equal to 1 year, not 2 or 3, just 1 year. Okay. All right. So then, and this is the account. So this is for the account. When I label them, this is for the account that pays 8%, and it's compounded quarterly, as they say. Compounded quarterly. Okay. Now let me see if this terminates. Let me see if that terminates. So 0.08 divided by 4. Yep, it terminates to 0.02, and then I add 1 to that, plus 1 is 1.02. So then I can rewrite this like this. A is equal to 15,000, parentheses 1.02 raised to the 4th power, because remember 4 times 1 was 4. Yeah, and then I want to type this in to the calculator. Okay, so then I have 15,000, and then times, and I can do parentheses. I can do parentheses here, and I can do 1.02, close the parentheses. So the parentheses are on top of the 8 and 9. So I did open parentheses, 1.02, close parentheses, and then this is where I use the exponent key. See this? So then I hit the hat key, and then I raise it to the 4th power, and then I can just hit enter after that. Okay, So I get A is equal to 16,236.4824. Okay. Yes, I'll just double check that. So we do that again. So I'm going to do 15,000 parentheses 1.02 close parentheses. And then I do raise to the fourth power. And then I'm going to round this. I'll just round this to the nearest cent. So the eighths in the cent, the eighths in the hundred spot. Okay. So is that 5 or more? No. So A is about 16,236.48. Okay. And they said it was compounded quarterly, but what if they had said that it was monthly compounded? What if it had been monthly compounded? Okay, well then N would have been 12. And that means the length of period, when they would add that money, increase that to the account, right? That interest earned, right, would be after 1 month, that would change, that would increase. Okay, some earnings. So this is compounded monthly. And then they might have said, what if it were instead of compounding monthly or quarterly, there's also something called semi-annual compounding. Semi-annual compounding, and that would be N is 2, twice. Number of periods per year, they compound that with twice, and the length of that period would be 6 months. Yeah, 6 months and 6 months gives you a whole year on that. Okay. Okay, now let's look at the other formula. The other formula is for the other deal is the one that's 7.86%, that was compounded continuously. So there you use the formula. See, under compound interest, you use this formula for annual compounding. Oh, for continuously, that's separate. This is separate from that, it's not the same. This is continuous. This uses the word continuously. Continuously compounding uses that idea of the E. So we use this formula. A is equal to P E raised to the RT power. So the P is still the 15,000. E raised to the rate is 0.08. No, it's not 0.08. It's over here. So it's 7.86%, and divide that by 100, which should give you 0.0786. So if I do 7.86 divided by 100, that's 0.0786. And then the time was also in 1 year. This is in 1 year. Okay, which is just 0.0786. That times 1 is itself. Okay, so then when I calculate that, I have the 15,000. And then I just press second and then the LN key. Second and then this LN key because that's where the EX is at. See, it's exponent already. So I don't need the little hat caret. It's already exponent. And then this times 1 is itself. So this is just 0.0786. That gives me 16,226.5729. So if I round this to nearest cent, the nearest hundredths, then I look at the neighbor, is this 5 or more? No, it's not. So A is about $16,226.57. So remember, we don't round up. They're like other time we were rounding up because we were trying to find capital P. We're not trying to find capital P. We're trying to find the A. Okay, and so we just look at the neighbor. If it's 5 or more, if it is, we add 1 to it. If it's not 5 or more, we keep that. Okay. So that was 9, and then that's why they say, if you look at both accounts and the money in both accounts, this one's a little bit higher. See this one? A little bit higher than this, not by much. If I were to subtract these two, I already have that in a calculator, so let me just do this. It's not really a negative. Because I already had that typed in, I just didn't mind. It's not really a negative, but I would have, this one is better by about almost $10, $9.91. So this is the better deal by about $9.91. That's the better deal. Yeah, and that's why they said over here, 8% compounded quarterly. That was the better deal, okay? All right. Okay. Okay, now let's go to 10. It says, how much money should be deposited today in an account that earns 3% compounded semi-annually, so they will accumulate to $11,000 in 3 years? Okay, it's a short amount of time. Okay, so here they want you to choose the formulas and then find out the amount of money that should be deposited, okay? And so these came out really light, so I kind of had to write over, like to the side, right over that. Okay, and then I have this comment here that says that, let's see. So, okay, let me write this down. So what we're solving, I'm going to write this down. So we're solving it's a compound interest. And we're using that formula for P, which stands for principal, which stands for also present value, okay? And this is when we're finding how much should be deposited now in order to have a certain amount, which they're calling A, in the future. And this is in an account in an account earning compound interest. So remember also that I have a note that says on this one that we're going to round up because we're going to be looking for P. Here's our formula. P is equal to A open parenthesis 1 plus R over N close parenthesis raised to the negative NT power. Okay. And so here we're going to be solving for P. Solving for P. Yeah, how much money should be deposited into the account? Okay. And you're trying to accumulate 11,000. Okay, so trying to accumulate 11,000. So this is the part you're trying to accumulate. In this case, 11,000. And you're trying to find out how much should be deposited. How much should we deposit? Excuse me. Okay, so I have a note to ourselves that we want to round up to the nearest cent or to the nearest dollar. So I'm going to say round P up to the nearest, depending what they're asking for, nearest cent or to the nearest dollar. And why? It would be to not fall short of meeting financial goals. Okay. All right. So then the other thing I want you to notice on this formula is we have a idea about negative exponents. See this right here, this negative exponents. So oftentimes in algebra, a negative exponent tells the reader that quantity can be rewritten, can be relocated, and our choices are a numerator or denominator. The way this is sitting right now, it looks like it's sitting in a numerator with the A, but this negative exponent tells us that we can relocate it to the denominator, and then you would remove the little negative on the exponent. So I want you to know that this is the same as this. Those are the same, saying the same thing. See how I push this to the bottom and see how I remove the little negative on it? These are equivalent. Excuse me. These are equivalent, saying the same thing. So I notice your book does tend to use the bottom one, and I can show you both in case you like the top one. They both will give you the same answer, but recognize that they're equivalent. And you can see on your teacher's sheet here, that was why I put or. See this or this. These are the same thing. All I did was push this down to the bottom. Okay. Okay, so if I substitute now, excuse me, this is what I have. So A is the 11,000 over parentheses 1 plus the rate was 0.03, because remember they said something about 3%, which is 3 over 100, which is 0.03. Okay, and then they said something about didn't they say semi-annually? So semi-annually is a 2. Remember we talked about that a while ago. Semi-annually would be the 2. And then you raise it to the n times t, so 2. And then the t was, they said it was, I believe they said it was 3 years. Yeah, 3 years, and there's a semi-annually 3% compounded. And 3 times 2 is 6, okay? So let me just figure what 0.03 divided by 2 is. Let me see if that terminates. 0.03 divided by 2. Yay, it terminates. See that? So I'm going to work with that. 0.03 divided by 2 is this, and then plus 1. Yay, so I'm going to rewrite it like that. So I have P is equal to 11,000 divided by 1.015 raised to the 6th power. See, that's a lot more user-friendly. And I can do that because it terminates. If it didn't terminate, then I'd have to work with that exact value, but it did terminate, and so I'm going to use that. So then now if you want to use this indie key, you can. Okay, so I have 11,000 over 1.015, and then you're going to raise it. See this little hat right here? Raise it to the 6th power. And then you can just hit enter because we have nothing else to type. So it looks like $10,059 and our change. And let's see, what did they say to round this to? And we're going to have to round up anyway, but did they want the dollar or the cent? They said round to nearest cent. Okay, so if I do this and go to nearest cent, see, that would be 64 cents. So I'll do that first. But remember the book said P needs to be rounded up. So then even though this is not five or more, we're still going to have to make this round up to 97 cents. So we're going to use P is about 10,059, and instead of leaving it 96 cents, we make it 59 cents. So we have $10,059, and that should be 97 cents because we rounded up. So let's see if we have that. Yeah, see how they have that? 97 cents. 10,059. Excuse me, 97 cents. Okay, so we have to round up. Okay, because we're looking for P. Okay, so we're looking for how much should be deposited. This is amount or money to be deposited in account. Okay, and then it's at today. And so this is a big lump sum. This is a big lump sum. You're not gonna put so much every month. This is a big lump sum you're just putting in, and then you're gonna wait 3 years to see. And your goal is to see it grow to 11,000. Yeah, so the chances, if you don't round up, then you're a little bit shy, you're short, and you may not reach exactly the financial goal. And that's why you do that, you round up, okay? Right. Okay, so that was 10. Okay, so we're halfway there. Okay, let's see. Now let's do 11. Oh, I know. Didn't I say I was going to do it the other way too, right? Didn't I say I was going to, let's see, just type it in the other way too. So let's see. So we do this other side. Purple. Let's see. So if I use this formula over here, let's see. Okay, so I have the 11,000. 1 plus 0.03 divided by n was 2 raised to the negative n times t. N was 2, t was 3, so that gives you a negative 6. Okay, so then you have 11,000 times 1 plus 0.03 over 2 to the negative 6 power, okay? And then, so similarly, 0.03 divided by 2, see, it still terminates, and then I add the 1. So I have 11,000, 1.015, and it's raised to the negative 6 power. Okay. So then I have 11,000, and in parentheses, 1.015, close parentheses, and then I'm raising it. So there's my caret key, raising it, and it's a negative 6. So this is, you have to be careful. See, you need to use, see the sign changer down here? Do not use a subtraction. You need the sign changer. It's a negative. There's your negative 6. And then you can hit enter after that. We should get the same thing. 10,059.96412. Which, yep, just match. See, this is the same as this here. It's the same. See? All right, that works out. And then you would still round up. So instead of saying 96 cents, you would say 97 cents. So you have to round up because you're finding P. So $10,059. It's like, do I go to 96 cents or to go to 97 cents? Go to 97 cents because you have to round up, because it's due to round up due to finding a P. If you were finding any other letter like A or any other letter, you wouldn't do that. But because you're finding P, you've got to do that on this test to make sure you have enough money. Okay, now I can go to 11. Okay, 11 says that if $50 is deposited at the end of each monthly into an annuity, so I guess at the end of each month, so what they mean to say you're depositing 50 bucks at the end of each month, and it's an annuity paying 6% compounded monthly, how much will be in the account after 20 years? And then what's the total, what's the interest earned on that? Okay, so we want to go to our formulas where we have the annuities. Okay, and this is the one that we'll be making use of here. We're trying to find A, and this is your payment that you're depositing. You're depositing $50 at the end of each month. So that's your PM, which your book also, I believe, can call it also a P. So if you note it as a P, that would be fine also, I believe. So, but you want to definitely go into the annuities part of that, okay? And so, let's see. So they do have the keyword. They do say annuity, right? Yeah, annuity, see? And it's still compounded monthly, but it's an annuity. So we didn't, these that we worked with, when we worked with these problems at the top, they hadn't mentioned anything about annuity, so we just stayed away from the annuity forms, but this one's mentioning annuity. And so on your choice, we're using, on all your choices, we're using this choice, which is E. Again, my printer was kind of low on ink. It was printing that lightly, so I had to hand write those to the side. But this is the formula that we want here. Okay. And so let me write that down for 11. Just making sure that matches that. Matches that, right, Klaus? Yeah, matches that. Okay, let's see. So I have some, let me read some notes I have here for you. I have here that in your book, they had some good ideas to share. I have here to consider taking advantage of the time value of your invested money, although you may be a long ways off from retirement, but to consider taking advantage of the time value of your invested money. Okay, so the time value of money says that, and you have one of your homework conceptual problems about this, that a dollar received today is worth more than a dollar received next year, or a dollar received a year after that, because money invested today starts to earn compound interest sooner, and so that's a good thing. And so that's why as soon as you start working, you know, like let's say you're done with college and you start working and you get your job and you're earning your regular paychecks from your job, it's good to put some of that money away, because you want to take advantage of that time value of your money. Okay. And so somebody who would do that in their early 20s, their mid 20s, will likely have over $1 million, you know, when they get into their 50s, if they're putting a good amount of money, saving a good amount of money away. Okay. And then also have here our goal with this formula here and this annuity. So it says our goal is that let's see, spend less. Oh yeah, this is another goal. Another goal in general when you're working and earning money is to practice spending less than you earn, and then to invest the difference. So make it a good habit to spend less than what you earn, and then also to invest any difference, so that your book talks, that comes out in the themes in your textbook. So your book does a good job about passing those themes along. So if you haven't read through the ebook, these are good themes that I'm stressing that are very helpful for you to know and practice. Now for this formula says that when equal deposits or equal deposit payments, called the PM, so these are equal deposits or equal payments. Okay, so when these equal deposits or payments, they call them PM, are made at the end of each month of in quarterly compounding periods. Yeah, so in yearly compounding periods. So there, it's either, you know, semi-annually, which is 2, okay, or quarterly, right? So 4 times a year, okay, or monthly, right, 12, or yearly, once a year. But when these payments are made at the end of each of n yearly compounding periods for an annuity that pays an annual interest rate R in decimal form, yeah, so R is in decimal form, so you got to move it 2 places to the left or divide by 100, compounded n times per year, we use to find the value A, and that's what we're doing here. We're gonna, this is the unknown. We're trying to find out what A is. We use this formula to find the value A of the annuity after T years of the formula that we use. We use this formula here, okay? And so for us, when I do my substitutions, the PM is 50. The rate is going to be 0.06 because they said in the problem that the rate was 6%, okay? So, you know, 6%, it is 6 divided by 100 is 0.06. So the rate, and then N was 12 because they said compounded monthly. So N is 12. Raised to the N, which is 12, and the years, see how many years was it? 20 years. Okay, 20 years. Okay, this is your PM. Okay, so 20 years. And what I do is I just right here, I'm going to just do compute 12 times 20 to get that. See, 12 times 20, don't forget, is 240 to get that done. Divided by R, 0.06 divided by N. Yes, I've got that. Okay. Yeah, so then when I clean it up a bit, let me see if this terminates. If this terminates, let's see. 0.06 divided by 12. Yep, see that terminates? 0.005. Okay, and then I'm going to add 1 to that. This is kind of curvy, but that's a 1 there. So plus 1. Yes, okay. So I have A is equal to 50, and then I have 1.005, and that's going to be raised to the 240th power, and then minus 1, and then all over. And remember what 0.06 divided by 12 was. Remember it was 0.005. Okay. Okay, so let's put that in the calculator, see what we get for that. So let's see. Clear this. Okay, so I'm going to do that ND key right here. Okay, so I have 50, and then parentheses. They have a bracket, but you can do parentheses. And so you can, if you want, you can do parentheses here. 1.005, and you're raising it to the 240th power. Okay, now this is tricky part. You have to be careful here. You need to push this down, so you do need to hit the little down arrow. Whoops, let's see. No, you didn't want to go all the way down, so I went back up. But you want to go down here and then -1 and then close it. Okay. And then over 0.005. And let's see, we're supposed to get $23,102. And then your change. What did they say to round to? Round to the nearest dollar. Round to the nearest dollar. And we're not going to round up. We're solving for A. So we're rounding to the nearest dollar, which means it's the ones place value. Okay. And it's not a P, so it's not solving for P. So what? So don't use rounding up idea. Okay. So let's see. So your nearest dollar is the ones place, and look at the neighbors. Is that 5 or more? No. So we have about $23,102 and, oh, they said nearest dollar, and $23,102. Okay, because it said round to nearest dollar. So dollar is ones place. Look at the neighbor. Is that 5 or more? No. So this stays the same. So it's 102. Okay. And don't try to round up. Don't say 103, 23,103, because you're not finding P like in the other problems. When you want to make sure you have enough so you won't fall short of your financial goal, we're not doing that. Okay. So here you're depositing $50 on a regular basis at 6%, and you're doing this every month, so monthly. So that's your N is 12, and you're doing this for a number of years, 20 years, and then that's how much you'll have saved up. Okay. Let's see. What else can I say about this formula? I don't know if, this kind of gave us a little hiccup here. What I have done in the past, if you see, you're flexible with this too. Sometimes I put the little -1 in front of this exponent, and sometimes that helps, because you saw how we had a little hiccup when I try to push this cursor down. So this is also the same, saying 50, and then here doing the -1, but then you have to put a plus sign, 1.005 raised to the 240th power, and all this is being multiplied by 50, right? And then on the bottom over 0.005. Sometimes that might work better for you. We could try that, and you would still use that N over D key. See that? And then do the 50 and then parenthesis, and then do the -1. So again, not the subtraction, do this right here, -1, and then plus, and then that base, so 1.005, and it's a caret key. It's raised to the 240th. See, and now you do want to go down. So now you want to type this. So then you just hit this down arrow. Oh wait, you still have to close it though, right? You still have to close it. So yeah, you're still gonna have to work with pushing that down. Let's see, if I press this key here on the side, see, if I press this key on the side here, That brings it down to put the parentheses. Yeah. And then divided by 0.005. And we still get the same thing. Yep, 0.044. Yeah, so I was thinking of doing this to avoid that little hiccup here, but we still have to work on that little hiccup because you still have this. So let me go back. Let me go back and type it one more time this way. Let's see. Just to practice that. So clear. So we have this ND. So 50 open parentheses 1.005 raised to the 240th. And then I'm going to press, this is where I did the hiccup. So I want to press this right button, see, to push it down. Yeah. And then I'm going to do the, okay, so then let me take this off. Instead of, this is not the down arrow, it's this one. Press this key. So you have up, down, across, and you have that key here. So you're pressing this here, and then you type -1. This would be -1. So this is minus, you can type it that way. Then it'd be -1, and then close parentheses. And then press this down. So then after you close the parentheses, then you type this down, and then you type 0.005, and we should get the same thing. Yep. Looks like I have a decimal, so let's see. Oh, it's because I didn't type 0.005. See, I did 005. I didn't do the point. But if I had done the point, then I would have gotten that. So that's what happened. Okay. So we'll do it one more time. This little problem is testing my patience here. Okay, so hit this arrow on the side, take away 1, close parenthesis, and then now I press this down key, and then 0.005, and then enter. And now it matches. Yep. All right. Okay. So I'm just giving you different little ways to work on that, see what's best for you, okay? Main thing is you'll make sure you have the right answer. So there's a couple ways to get to that when you're typing things in. All right, so that was 11. Let's see. There's a second part to that question, wasn't there? What was the other question? Let's see. Yeah, because see, this is the yeah, they wanted to know, okay, how much will be in the account after 20 years? So you're going to have this much in the account after 20 years. But then they wanted to know, do they ask for the interest? What's the total? Yeah, they do ask, what's the total interest earned? So they are asking the question. They just, I don't know if I whited that out, or they didn't answer that other question. What the answer to that? Where's the other answer for that? They didn't put that there. What is the total interest earned? Okay, so yeah, because you are going to have some questions on your test where they're going to ask for that. What's the interest earned? So it says, what's the interest earned? Yeah, because remember you're depositing $50 every month, right, like clockwork for 20 years. So you've got 12 months and 20 years. Okay, so let's see how much time. 12 times 20, that's 200. Yeah, we had 240 earlier. We calculated that somewhere. You have 240 deposits of how much money? It was $50, right? So you have 240 times $50. So 240 deposits of $50. So see how much money that is. 240 times 50. Looks like it's $12,000. Yeah. And now to find out how much interest then, how much interest are you making? So then you know now that after 20 you have 23,102. So you want to subtract 23,102 minus the 12,000. So you have your A, and you're subtracting the amount of I guess all your deposits. So if you put away $50 every month in a year for 20 years, you're putting away 12,000. So then you just have to subtract. So 23,102 minus 12,000 is 11,102. And that's your interest earned. Yeah. Which is good, because you normally won't, hopefully wouldn't miss $50. Even 25 is good. If you can do 25, but if you can afford to put away $50 and not miss the $50, then you just have that as the more experience you have and the more money you make, you can increase that. But if you just stick with the 50, you're going to make 11,102 interest earned on that. Okay. So what if the time needs to be calculated? Yeah, what if the time needs to be calculated using subtraction? Oh, I have here, what if the time needs to be calculated using subtraction? So what it means by, it says, what if instead of saying like 20 years, that you're putting this away for 20 years, what if it said something like the deposits, you begin these deposits at age 28, and you're going to continue this putting $50 away until you plan to retire, which let's say you plan to retire like at 70, then what would your time be? So then your time, because here they said that the time was given, right? They said the time was 20 years. But what if you were 28 and you decide to put $50 away every month, and you keep doing this until you're 70, because that's when you plan to retire, and you stop doing that. So then you would just have to subtract the 70 minus the 28, like when you ended and when you started, and then that would give you 42 years. So I think we're having another problem that's going to come up that's going to need to use subtraction for that, okay? But there's a need to know how to do that, define your time that way, okay? Okay, now let's go to problem 12. So 12 says that a passbook savings account has a rate of 8%. Find the effective annual yield, rounded to the nearest tenths of a percent, That's one decimal place. If interest is compounded semi-annually, that's twice a year, and then they want you to select the correct formula, okay? Yeah, and some of your problems on your tests, they're going to have, some of them are going to have a list of formulas, but not all of them are. Some of them will have a list of formulas for you to choose from, but not all of them, and that's why you're allowed to sheet as well. So here they want you to choose, and so the keyword here is effective annual yield. This is a keyword here. And that would be the formula that's got the Y involved. So again, this came out very light, so I had to type the formulas on the side, but this is the one that we're leaning towards, and that would be choice E. Y, capital Y, is equal to this quantity, 1 plus R divided by N raised to the N power minus 1. Okay. So let me see. Let me write this down. So 12. Effective annual yield, which is also an effective rate. So simple, let me read this out loud. So simple interest rate, this is like a definition from your book. And let's see if I can get your page number. Let me see what section it's in. It's going to be in section 8.4. It's under compound interest. It's under compound interest. Compound interest is the section title for that, okay? And let me see. Yeah, and I said 8. It's actually chapter 7. It's just that the book that I have referenced, for some reason the book that I have is off from the My Labs Plus reference chapters, I believe. So I have a book here that says 8.4, and I'm looking at it has the yield, but then in My Labs Plus, it's off a chapter because it says chapter 7 is where the problems are being pulled from. So we must have like the book must have been updated. Like the My Labs Plus is probably from a previous textbook edition. Yeah, it kind of throws me off a little bit, but sorry. But it's that's why I said compound. It's compound interest. So I think for you it would be 7.4 compound interest. So sorry about that. So if I read the definition, so I won't even give you a page number because the pages probably don't coincide. I have here 525. It's probably not the same pages for y'all in your ebook then. But effective annual yield, effective rate says simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest as stated as a stated rate. Okay, so then they have this really helpful rule of thumb. Know that your one's investment is estimated to double by this rule of 72. So the idea is that you would take 72 and you would divide it by this effective annual yield without the percent sign, and that would give you the amount of years it takes for investment to double. Okay, so that's a really good rule of thumb to have. So let's say right now you have let's say you have $10,000 in account right now, and you're wondering, well, how long will it take to double that to 20,000? Well, if you know your effective yield, you would take 72. So this is called rule of 72. You would take 72 and divide it by whatever. You need to find out what the effective annual yield is. That's the idea. So years it takes for investment to double. So that's like a rule of thumb, okay? All right, so the book talks about that. So is approximate time for an investment to double. Okay. All right, so that's just an aside from our formula. Now the formula we need is that Y formula, which is right here. So I'm gonna write this formula down right here. And anytime you're trying to find the effective yield, you're gonna use that formula. So for us in this problem, the rate, I had a little bit of keyword about the R, your rate. Usually they use the word nominal for these problems with effective annual yields. They use either nominal or they say you have a standard interest rate. And of course, it should always be in decimal form. You move it 2 places to the left, divided by 100%, by 100. And then the N is the same. It's still going to be N times a year. And it's still compound interest is going to be paid. That doesn't change, okay? So it's either once a year, 12 monthly, right, every month, 12 times, or semi-annually twice, or quarterly. Yeah, so that this still applies. So this idea, go back to this table. Let's see, where's the table that I made for y'all? Yeah, so when I had this table at the end, I had quarterly, N is 4. Monthly, N was 12. Semi-annually, N was 2. Yeah, and this on this side, those numbers, this side was the length of the period. So this is 3 months 1 month, 6 months. So just be careful here with the quarterly, because sometimes people will put this number down wrong. They know quarterly means 4, but they might put 3 instead here. So just be careful with that. So the ends are 2, 4, and 12. 2, 4, and 12. Number of times a year compounded interest. So just be careful. Those are common mistakes that are made sometimes when we're doing these problems. Okay. Okay, what else do I have about this formula? Okay. Oh yeah, and also what you might want to do, this is what we might suggest on your formula. What you might want to do in your formula is do this also times 100, because it is this effective annual yield. Without that, it's given. Without that, it's in decimal form, but you do need to convert it to a percent. You do need to convert it to a percent. So I'm going to do this times 100, and that way it's already converted into a percentage already. So you have permission if you want on your formula sheet. Permission if you want your formula sheet to do that times 100. Okay. Because on your answers, you'll have to do that too. On your answers, change it to a percent. Okay, so then we have y is equal to 1 plus the rate was, I said, %, so 0.08, right? Because 8%, 8 divided by 100, right, is 0.08. And then your n, compounded semi-annually. Okay, so n is 2, right? And then look, this is just raised to the n power. So you want to be careful. You want to be careful because, you know, some formulas are raised to the nt, and some are raised to the rt, and some are just raised to the plain n power. So you do have to be careful and double check. This one's just to the n power. So be careful. And n is 2. And then we have this minus 1 and times 100. And again, you know, you can be flexible. What I sometimes like to do, this minus 1, I sometimes like to put that, you know, in the front, minus 1 plus, and then 1 plus 0.08 divided by 2 raised to the second power times 100. Sometimes this -1, this minus 1, negative 1 bothers me, so I put in the front just to take care of that. It's a negative. Here it's a minus 1, but when you put it in front like this, it's a negative. So here it's a minus 1. If you're going to leave it there, if it doesn't bother you, here it's a negative. So you need the sign changer. So here you need the little sign changer, where here you don't, right? Here you don't. So just be careful. But I like to oftentimes switch it around like that. It's still the same formula. And let me see if this terminates. Let me see what 0.08 divided by 2 gives me. 0.04, yeah, and then plus 1. Yeah, 1.04. Okay, so this is going to be -1 plus 1.04 raised to the second power times 100. Okay, so that'd be fine. Or if you want to stick with the other way, 1.04 raised to the second power minus 1 and then times 100. So Your call on that, okay? So either way, you don't have to worry. We're not gonna, there's no need for this key here. So we're gonna do, if I do this one first, 1.04, then the hat key, the caret key. So this caret key, raised to the second power. And then you see, this is why, either way though, even if I put the negative on the front, I still have to bring it down because I need this times 100. But this is 1.04, and then I'm going to press this side button here. So I'm going to do this to show you the side button here on those keys. So I have up, down, side here, these pads. So I did 1.04 and I press this to the side here. Now it brings it down, and then I do -1, and I should do times 100. Okay, that doesn't look right because that's a -98. That's not right. Oh, let's see. I'm supposed to get 8. Did I get 8.16? I'm supposed to get 8.16. So let me see, 1.04 to the second power -1 times 100. I'm not seeing my mistake readily. Let me do. What did I do wrong here? I don't see it. Okay, I really don't see what I did wrong when I typed that wrong there. I'm supposed to get 8.16. So let's see. Let me just write this down. I'm supposed to get 8.16%. Maybe y'all are getting ready. Let's see. Let me go back. If I type this one, which is usually my favorite anyway, I usually like to write it down first. Let's see. -1, and then plus 1.04, and then I raise to the second power, and then I push it down. Oh, here, push it down, and then times 100. Oh no, now I'm getting 107. That's not good. I'm supposed to get 8.16. Let's see, what am I doing wrong? Let's see. I can show you. I did, when I redid this earlier, I got that this weekend. So I got 8.16%. Did I make a mistake there? Well, no, because if these are right, I would have gotten the same thing on the same thing, the right, and I'm getting different numbers. So let's see, let me make sure. So the rate, so I plugged in the 0.08 over 2, 1. I'm looking at the yield formula. And maybe because I did the times 100, but it shouldn't matter what point. Usually I do this and then multiply by 100 and I get that percentage, but it shouldn't matter what point I do that. It's at the end. Let me make sure I do. Let me see. Let me do 0.08 divided by 2 is 0.04, and then I add 1 to it. It's 1.04. And then I raise it to the second power. So let me try without the 100. So if I do 1.04 raised to the second power, and then push this arrow to bring it down, and then minus 1 equals, and then do times 100. Then I get 8.16. So it doesn't like it when I do, okay, we have to be careful here then. We have to be careful here because maybe I need brackets. Maybe I need brackets around this because it doesn't look like it likes it with the times 100. So you either do it at the end, because the only thing I did differently was I didn't put it in brackets. If I do the -1 first, -1 plus 1.04 raised to the second power equals, see, and then times 100. Yeah, so if you're going to do it all in one swoop, it looks like it needs to have parentheses around this. Let me try this again. So if I do 1.04 raised to the second power, then I push this down, then I subtract 1, and then I do times 100. It's not going to like that. Nope. So I need parentheses. I need to do parentheses, then -1 plus 1.04 raised to the second power, and then close it. And then I can do times 100. Yeah. Okay, so let's go back to your form. This is important. So either you type this in like that, type that in, and then after you get an answer, you do times 100. If you're going to include the 100, then you need like another set of parentheses or grouping symbols, which would mean like brackets in this case, for example, because I already have parentheses here, and then times 100. So you do have to be careful with that. Okay. So then let me go back over here and use that in red. So let's see. Yeah, I have to be real careful. I have to go back way over here and do something like this, like in red, for me to catch that. Which I didn't realize that until I typed that in just now. Yeah, that's got to be it. Yeah, so now if I type in, either this one, I'll do both of these and I should get the same thing now. So one with the -1 in the front. So parentheses, -1. Highlight that. Okay, so the topping, -1 plus 1.04 raised to the second power, and then push this down, close it, and then do times 100. Okay, or parentheses 1.04 raised to the second power. Okay, -1, close it, and then times 100. Yeah, it's 8.16%. And then they told us to round to nearest tenths of a percent. And this tenths would be right here, tenths place. And is that neighbor 5 or more? Yes, so add 1. So y is about 8.2%. Yeah, so remember you have like your ones place, and here's your decimal, and then you have tenths, and then hundredths. Okay. All right, I'm gonna take a break. I'm gonna stop there. So we're at 12, and then later sometime today I'll go back and hopefully do one more recording hopefully, where I can get numbers 13 through 20 done hopefully. then, okay? All right, okay, so see you in a bit then. My math. Let's see.